Cool. Yeah, I'm not
Sure,
sure what to take from the top, but
does that look like it's recording now? Oh, yep, it's saying.
recording somewhere.
Hello, folks. Sorry, we just hit recording, but I didn't get very far. We just quickly introduced the maintainers of the project who are on this call at the moment. So that's Dan Muvaff and myself, and here comes Jared, who is also a steering committee member and maintainer. And Phil is, I guess, sort of an honorary maintainer. He's our product manager at Upbound, who helps us out a lot with our sort of plans and roadmap for Crossplane from Upbound's perspective. So I was just saying that Upbound was launched by the creators of Rook, including Jared. It is open source, open governance, obviously a CNCF project. It builds on Kubernetes. So this was something that really attracted me to the project in the beginning. I really liked the idea of being able to sort of manage things that weren't containers via Kubernetes effectively, like manage, I was an SRE for about 10 years personally before I joined Upbound. So the idea of being able to declaratively manage my databases and whatnot, caches, et cetera, from using the Kubernetes sort of resource model from the Kubernetes API was really appealing. And this, at the time that we started Crossplane, I believe that we were kind of the first ones in that space, I think. So the main sort of feature areas that we have with Crossplane, which we'll go into in a bit more detail, and as I say, hopefully demo, you can provision infrastructure declaratively from the Kubernetes API. So what we mean by that is we represent anything that a cloud provider or on-prem, bare metal, anything with an API basically, we consider those to be external resources. So the AWS RDS API, for instance, has an RDS instance, fires you off an RDS server to go and create databases on. We consider that an external resource. Crossplane lets you manage those as what we call managed resources, which is a Kubernetes custom resource that corresponds to one of those. So sort of the base layer of Crossplane functionality is we have a bunch of CRDs that represent cloud infrastructure. And, I keep using AWS as an example, but we work with the AWS folks, we work with the Azure folks to build our providers. We have a GCP provider. There is an IBM cloud one on the way. There is was Packet, now is Equinix Metal one. There's tons of providers out there for Crossplane. So that's kind of the bare minimum that we have. You can just manage your infrastructure declaratively, but building on top of that, a feature that I think is really cool is we have something that we call composition that lets you, I see your question. I will get to it in 1 second. I just finished my thought. We have a feature called composition that lets you compose these sort of low-level primitives into high-level sort of abstractions on that. And that's really cool for SRE teams, in my opinion, because it lets you as sort of, if you're a platform team or an SRE team with a bunch of infrastructure, sort of with a bunch of developer teams who need infrastructure, you might not want to give them just the raw RDS API. You might want to sort of simplify it a little bit for them or put some opinions on it or like meld it to your company's opinions. Let me just stop over here and go answer live to this question. So how does it differ from Terraform is a really great question. I think there is kind of I just clicked answer live. I'm not super familiar with Zoom, so I hope I'm answering this correctly. So there's a couple of things. One, just being built on the Kubernetes API gives it a little bit of a different look and feel. Terraform is declarative. Terraform has what I would call high fidelity representation of cloud resources in their configuration language, the Terraform flavor of HCL, HashiCorp's configuration language. One difference is that most folks are using the, I think the open source CLI version of Terraform. So when you want to go and deploy all of your infrastructure or make a change to it, you sort of run Terraform on the CLI, and it does sort of a one shot. It sort of computes the graph of all your infrastructure, make sure everything's good, and then goes and sort of applies that and updates everything. No, and there are some other different sort of builds of Terraform or Terraform Cloud and Terraform Enterprise that I'm not personally that familiar with, but I know that they do a little bit more than that. But one big thing for us is that we're a control plane. We're not just a CLI tool, so we will constantly reconcile toward the state of truth. So if you tell us that this RDS instance should be 30 gig, and someone goes and edits it and says that it should be 20 gig now, we'll notice that because we're polling, we're every 30 seconds by default, we look at the state of the world, notice that things have changed, and make the state of the world look like your declarative state. Very similar to what Kubernetes does, or basically the exact thing that Kubernetes does with running containers. You know, if you go and shoot a Kubernetes container, or if one stops running or a node dies, Kubernetes will make sure that's running again. We do that, but for all of your infrastructure. Another nice thing about the fact that we are a control plane and that we expose this API is that we're sort of standing on the shoulders of giants with the Kubernetes resource model and the Kubernetes API. So when you want to automate Terraform, or if you want to sort of provide Terraform as a service with the Terraform's an awesome tool, and I used it for years and years as an SRE before I came and worked on Crossplane. But one place that I think Crossplane shines here is because we just have the REST API of Kubernetes. You can interact with Crossplane with whatever tooling, whatever language you like. Anything that can send, JSON REST HTTP requests can be used to be an interface to your declarative state. So, for instance, you can use Terraform in front of Crossplane if you want. You can have a Terraform provider that configures Crossplane. You could also write a Python script, or you could also build a web UI around it. You can do sort of whatever you like there. So, in my opinion, they solve similar problems, definitely, but Crossplane definitely has the advantage of being a control plane with an API sort of thing. It's maybe a little bit more of a modern, a little bit more of a scalable take on the problem space. Does that answer your question? I'm not sure if you have any way of letting me know. Awesome, thanks. Cool, and so I think where I was getting to was I was talking about this offer your own declarative infrastructure APIs, which is sort of where you can, which we'll get into a little bit later. But the other main feature area that I think is also really cool is that Crossplane is the open source Kubernetes implementation of the OAM, Open Application Model. So this allows you to also model your workloads, your actual sort of, not so much your infrastructure like databases, but more things like the actual services and processes and jobs that actually do compute. And OAM has a really, really nice sort of developer-friendly UX that we've spent a lot of time thinking about how to sort of make running applications and workloads more developer-friendly, and that integrates tightly and nicely with Crossplane. So you can sort of spin up your apps, and you can spin up the infrastructure that they need all in the same place, all in the same API, nice and tightly coupled. Okay, so this is just a little bit more of the history, and I think I mostly covered this stuff. But I will say that the point that it makes here, where Jared and friends, the folks who started the project, when they sort of saw basically the persistent volume claim API in Kubernetes and sort of took that idea and expanded it to everything else. That was something that really sold me. Like the first time I spoke to the folks working on this project, I was like, "Oh, that's something that I want to be involved in. That's a really great idea." And as someone who'd been working on platform teams, I could personally immediately see. I was like, "This would have been so handy with my developer teams that I was supporting in my previous jobs to be able to sort of offer them this sort of self-service interface to managing their infrastructure needs." So this kind of this diagram kind of does a good job, I think, of illustrating a little bit of how what I just discussed worked. So you can kind of see that from the top going down, you've got your sort of application developers and operators. So we break folks out into different personas. We kind of think about who's doing what when we design APIs, and then when we think about designing Crossplane. So your application operator is the person who's, and sometimes these will all be the same person. It really depends on how your organization works or how your team works. But in theory, the application operator is the person who's actually deploying the application. Let's say you've got the billing app for your company. The team that deploys that, they're the application operators. And in some companies, maybe that's the SRE team. In some companies, it's maybe the folks who develop that thing. It's sort of all the same people. We also have the persona, speaking of developers, of the app developers. So that would be the people who actually code and maintain and ship the billing app sort of thing, make it available to deploy. And then we have the infrastructure operator, or operators, who are the folks who might have opinions about things like, should your databases be replicated? Like, what database should you be using, or what cache, or just, how should your infrastructure be running, sort of thing. And again, all three of those could be the same person in a small company, or in any company, depending on your how you like to do things. So at the top of this, you can see that sort of the app dev and ops interact with OAM. OAM gives them sort of a nice interface to basically deploy Kubernetes applications. Sort of OAM deals in things we call workloads and traits and application configurations. And by convention in Kubernetes, those tend to render out into Kubernetes deployments, services, jobs, things like that you're familiar with already. And then at the sort of beneath the line in the middle part of this diagram, you've got the infrastructure APIs that you can sort of, your infrastructure operators can define and compose with Crossplane that can be consumed by those OAM apps. So I think I've touched on most of this, but this is just sort of making the point that, this is all declarative. It's all Kubernetes YAML. So, if you're familiar with writing deployments and pods and services and all that good stuff, it's, it's not too alien to work with Kubernetes, to work with Crossplane. And I think this is also another advantage in that there's some amount of sort of tooling consistency if you go and use sort of Crossplane to manage your infrastructure. There are other tools outside of the Kubernetes ecosystem. Again, Terraform was mentioned before. There's things like CloudFormation, that can help you with this, and those are great tools. But one thing is that if you are providing those if you as a sort of a platform owner or as an infrastructure operator, SRE, are picking a way to give sort of self-service management of infrastructure to your team, one advantage of staying inside the Kubernetes API is if your team is already using Kubernetes to deploy their apps and things like that, your users might be familiar with Kubecon or whatever, dashboard you have for them, sort of thing. They might know this API kind of a little bit already. And so using that to manage your infrastructure as well as managing your containers and your apps and things like that can be make it a little bit less for your users to have to learn and understand. Fewer tools. So those primitives, those managed resources that I talked about before, I don't actually know what the current count is of them, but there are a lot. We have tens and tens of resources in AWS, here, including caches, Kubernetes clusters, databases, etc. Like Kubernetes, we have various levels of maturity for these APIs. So we tend to start things in V1 Alpha 1. So, some of these are sort of just been added. People are sort of starting to use them and finding some bugs and things like that. Others are at V1 Beta 1, which are, more reliable. So a lot of the core resources, things like RDS instances, GKE clusters, EKS clusters, Cloud SQL instances, Azure SQL servers have all made it to V1 Beta 1, which means that, people are out there using them in production, and we see relatively few of them. I won't promise that they're bug-free, but they're fairly reliable. So now we're sort of getting back into what we tend to call in the maintainer team at least composition, which is this way of defining an infrastructure resource of your own sort of abstraction. So you can see here in the example, when you've got these cloud primitives, one thing that we found pretty quickly, actually back in Crossplane, we actually used to just sort of follow pretty much exactly Kubernetes' persistent volume claim pattern. There was kind of a one-to-one between any particular kind of resource and a user-facing friendly abstraction to it. So a great example that I always go back to is databases. We had the AWS RDS instance, the GCP Cloud SQL instance, and we provided what we called resource claims in front of those, which was like a persistence volume claim to a persistent volume in Kubernetes, if you're familiar with that sort of storage abstraction. And we found a couple of things pretty quickly. One is that it's really tricky to have a generic abstraction that is all things to all people, that works for everyone. So the idea of saying, okay, you can have an RDS instance, a Cloud SQL instance, an Azure SQL Server, your on-prem you know, database server running on a VM somewhere sort of thing. And then we can give you this one Kubernetes API type called, you know, maybe a MySQL instance or something like that, that can sit in front of all of those things. And, you know, it'll have all the configuration you want and it'll apply to any cloud or whatever scenario you're in. It just didn't work out. We found that there was sort of a lowest common denominator problem where you kind of either have to put all of the fields of all of the possible sort of backing resources on there and just let people know that, hey, actually in you know, my on-prem setup, only 3 of those fields will work, or you have to put sort of the set that is shared of all of those fields. And you find that for a database, you know, it might be just size is the only thing that you can pick, and then everything else has to be sort of done elsewhere. So we found that to be a bit of a limitation. Another limitation we found is that commonly when you want this sort of high definition, as I think about it, or like a really good representation of all the features of a cloud and the cloud's APIs, you'll see that all of the projects that sort of get into this space, as far as I can tell, so that's us, Terraform, ACK, Google Config Connector, Azure Service Operator, tend to give, again, what I call high definition representations of cloud APIs. So that means that if your AWS RDS API has 10 fields, we try to represent those 10 fields as closely as possible to RDS. And one of the advantages of that is if you want a field and it is supported by RDS, it works almost exactly the same way in Crossplane. It also means that we don't make assumptions or opinions about how you're going to use your infrastructure. We won't sort of say, okay, we think it would be easier if these 2 fields were merged into 1 field. So we'll do that to help you. Well, that might help most people. There's going to be someone out there who's like, oh man, I really wish that those were still 2 fields because now I can't use Crossplane to do what I could do with the underlying API. So we keep these resources really high fidelity. And one of the downsides to that is you'll run into certain APIs where it's not as simple as just making one API call to say, give me a database. So Azure is a great example of this. This is not a knock on Azure. I think this is a really cool design decision that they made, that if you just ask for a SQL server from Azure via their API, you get a SQL server that's not open to the world at all. It's secure by default. It's firewalled off to everyone. And then you have to go and make other API calls to actually open up ports in various different ways, depending on how you want it to be configured. You want to say, you know, hey, you know, let this VPC network or let this subnet access this, or let these IPs out on the broader internet access this time. So what you're actually doing is creating multiple managed resources, multiple resources. So you're saying, give me a SQL server, maybe give me a resource group for those to go in, and give me firewall rules for my SQL server. And at that point, you know, you might be thinking, well, hey, you know, all of this is pretty complicated. I'd be happy to just give my customers, give my users the ability to create a database using Azure's API. But now you're saying to your customers, okay, if you want a database, you have to really put your SRE hat on and really be thinking about how is this configured. You've got to say, I'll answer that question in just a second. You've got to say, you know, okay, now you've got to create a SQL server. You've got to create firewalls. You've got to do all this stuff. You're creating maybe like five resources in the cloud. And so having one abstraction that maps to those that's sort of preordained is really hard. So with that problem context all set, I'll go and answer this question, then I'll get back to that. Is there a single binary for each cloud provider or for each service? Effectively, yes. So Crossplane actually runs as, you might think of it as like a set of controllers or a set of operators in Kubernetes. And one feature that Dan has done a lot of work on lately, which is really cool, is we actually have our own kind of opinionated package manager for this kind of thing. So hopefully we might get time to do a demo at the end and you'll see this in action. But when you install Crossplane with a Helm chart, or however you could install it with Case Summit or Customize if you wanted to, but we happen to package it as a Helm chart. And that gets core Crossplane installed. And by default, core Crossplane doesn't actually do very much, to be honest. It sort of installs OAM and installs this composition support and package manager support. And then you can basically declaratively say, hey, I need AWS support, please. And then we'll go and pull down AWS support and we'll start it running in your cluster. Or you can say, I need GCP support. I need Azure support. So if you know that you're an Azure shop and that's all you're ever going to run, you don't need to have the code running that runs GCP or runs AWS or anything like that. It also just allows granularity of upgrades. If you do use, let's say, GCP and Azure, and there's a bug that you found in the Azure provider, you can upgrade just that Azure provider declaratively without touching core Crossplane or GCP. Does that make sense? Does that answer your question? gonna take a sip of this. This is a pint of cold brew coffee. I'm not drinking beer live on a cam. So I think I was just setting context for this declarative opinionated API. So we took this concept that we used to have called resource claims, where we just determined the schema of a bunch of resource claims basically and offered a handful, 10 or so to folks. And we've now put that into the hands of Crossplane users. So we have what we call composite resources, or XRs for short, since CRs was taken by Kubernetes, which is a way that you can basically define your own schema. You give us a little open API schema and you tell us like, hey, I have a resource, it's called Acme Corp MySQL. And it has only the configuration fields that my developers or that my team cares about. It has only maybe storage size and engine version, or maybe it has, region, or whatever you want. You can pick and choose what goes in there. And then you can write sort of a relatively simple, by comparison to the other tools, at least in this area, in my opinion, you can write relatively simple, what we call compositions that say, okay, when you see one of these claims that, when one of your developers or one of your users creates one of these claims, we'll use a composition to actually output multiple resources. So you can take that problem of having 5 Azure resources that you need to create to actually spin up a usable Azure database and abstract those behind one Acme Corp MySQL. And this also allows a certain degree of portability. If you're interested in that, you could also teach Crossplane how to turn your Acme Corp MySQL into a GCP database as well, so that your sort of users can easily cut back and forth between using Azure or GCP or AWS or where your databases come from. And again, I keep using databases, but I can be talking about caches, Kubernetes servers, VPC networks, all of that good stuff. So this is a little bit of an illustration of that. And I think that this actually has almost that exact Azure scenario I talked about here. What you get up here is, so this line, interestingly, for folks who are familiar with Kubernetes, is actually the boundary between namespaces and the cluster scope. So down here in a namespace, you've got your application operator, and they're saying, hey, I'm deploying an app. Maybe they're doing it via OAM. And the app is saying, I need a MySQL instance. And this MySQL instance, again, this is something that you've defined. You've taught us about you've taught Crossplane about the schema of this and what it is, what kind it is. And then Crossplane says, okay, I've seen that you want a MySQL instance. I'm going to create a cluster scoped composite MySQL instance, which again is schema that you've defined. Those things actually have an almost identical schema. You can kind of think of the namespace one as like a proxy for the cluster scope one. The cluster scope ones we think of as like, that's what the SREs, that's what the sort of platform operators will work with. They can look at all of those in one place, in one scope, no matter what namespace the sort of the infrastructure originated from. But then you've got these like namespace claims, and we call them XRCs, that your users can write, and then they can only see the claims within their namespace if that's how you like to configure it. And then, so when Crossplane sees this composite MySQL instance, it's not pictured here, but it's actually going to use something called a composition to say, oh, I see that I've seen a composite MySQL instance. I know that I want to use the Azure composition, so I can render that out into an Azure MySQL server, a resource group, and a firewall rule. And all of those are powered by a provider Azure. Or, alternatively, you could be the Amazon one, which will pull in RDS, DB subnet group, security group, et cetera, et cetera. And you know what? I'm actually going to pause walking through these slides and kick off the demo, because I want to demo the AWS one, which has about 11 million resources in it, and those take some time to come up. So I'm going to just switch over my screen sharing for a moment to my terminal. All right, now hopefully folks can see my terminal instead of what we were looking at before. And so here, I should have a fresh kind cluster with nothing in it. By convention, we install Crossplane in a namespace called Crossplane System. So I'm going to install the Crossplane Helm chart. Alrighty. Make sure that seemed to work as expected. Yep, there you go. You can see some of our containers coming up. So you can see the Crossplane deployment coming up, and then the OEM runtime deployment coming up, and the RBAC manager deployment coming up. I won't talk about this too much, but the RBAC manager one's a little bit interesting. In Crossplane, we automate a lot of the RBAC stuff that you might need to do because Crossplane creates a lot of new API types in Kubernetes, and it's quite onerous to write RBAC rules manually for those. So the RBAC manager runs with privilege escalation. It can grant RBAC roles that it doesn't have. However, the reason that's a separate deployment is because if you consider that to be a security risk or untenable for you, you could just not deploy the RBAC manager and manage RBAC yourself, and still get the full functionality of Crossplane. All right, so those are coming up. So now we're going to install some providers. This is what I was talking about before. You've got your Crossplane package manager, which is built into the core Crossplane pod, and that allows you to hopefully copy and paste from over here. There you go. Kubecon Crossplane is our little CLI tool that we built to sort of automate some of this, and I've just installed provider AWS. I could also let's install provider Azure. See that there's two providers. And they've spun up and they are healthy and they are running. So this package manager creates a revision for every package you installed as well. So if you went and installed the next version of this, you can choose to sort of roll forward safely. You can kind of install it and then roll forward later or roll back to a previous version. It gives you like a sort of a relatively safe way to roll forward and back between provider versions. All right, now I'm going to little shell script. What this shell script is doing is for any provider I've installed, it's just creating secrets with the credentials to that provider. So in this case, for AWS and Azure, I should now have what we call a provider config. Actually, a series of them for all of the names that we use in our examples. So these provider configs tell Crossplane how to connect to your provider. So in this case, this is the default AWS one. By the way, if you create a provider config called default, then everything will use that by default. So you don't have to specify it elsewhere when you create a resource. So in this case, we say that this provider is for AWS, the provider configurations for AWS. The only thing it configures is credentials. It's going to get those credentials. You can see source secret, and it's going to pick them up from a particular secret. In AWS, you could also use IRSA to do this, so you don't have to use a secret. You could say the source should be IAM-based authentication, but I'm running a kind cluster in GCP at the moment, so I'm not going to use AWS IAM to authenticate. So what I'm going to do now is install a special kind of package called a configuration. A configuration is kind of what it says on the tin. It configures Crossplane with support for new resources. In this case, I am going to install the, oh no, I installed the wrong one. That sounded contrived, but I really did install the wrong one. So you can see that there's a configuration there that's being installed. I don't actually want that one, so I'm going to make that go away. Let's go on. What I actually want is this very similar one. All right, so I'll install this configuration. Then I'm going to kick this off just before I answer this question, because this is going to take a minute, so just give me a second. Webcall. All right, so this configuration is installed, and you should be able to see now XRD and a composition. So an XRD in Crossplane is like our opinionated version of a Kubernetes CRD. It extends Crossplane with support for new types. And so in this case, we're installing support for a Postgres instance. And this is from our documentation. This Postgres instance is some YAML. Actually, I'll show you that. This guy. to see here the schema of this. We tell it what names to have, and then here we write an Open API v3 schema, and we say that this is going to have storage GB, which is basically the only field that it has. But this is what you as an SRE would be able to write for your users. And in fact, I wrote this one as YAML. You create it to Crossplane, and then Crossplane now knows that, okay, it should serve a type of resource called a Postgres instance via its API. And then that composition is, in this case, really, really long because it spins up a lot of resources. But this composition basically teaches Crossplane how to spin up an AWS RDS instance. In this case, it actually spins up all of the supporting network stuff required to run an RDS instance. So it creates VPCs, it creates subnets, it creates DB subnet groups, it creates IAM policies, it creates, I think it creates IAM policies, it creates security groups. So it's doing a lot of stuff behind this simple user-facing concept of, hey, give me a Postgres server. So now I'm going to apply the resource claim for AWS. So, all right, so now we should be able to see Postgres. All right, we've got this PostgreSQL instance, which is coming online. You can see here it's waiting for its composite resource to be ready. So this Postgres instance is actually, I'm in the default namespace. This Postgres instance exists in the default namespace. It's bound to a composite PostgreSQL instance at the cluster scope. There you go. You can see that this composite PostgreSQL instance, which, and by the way, these could be named whatever you like. We named it composite to sort of clarify things in our documentation, but you could name it widget and foo if you want to, has basically spun up all of these different resources of VPC, subnet, as I was saying before, DB subnet group, internet gateway, security group, et cetera, and finally an actual RDS instance to live in all of those. And so this is going to take a few minutes, primarily for the RDS instance to spin up. I think if I do kubecon get AWS, that'll pull up all the AWS resources. It might be a little bit long. You can see that they're all spinning up here. A lot of them are ready and synced, which means they're mostly good to go, but the RDS instance takes a little bit of time, so that's not yet ready. So while we wait for that, I'll go answer questions. What are the operational differences between XRCs and XRs? I'm not 100% sure what you're asking here, but I'll do my best. So XRCs are composite resource claims, and XRs are composite resources. And the reason, and so schematically, these are almost identical. And in fact, I just merged a PR, sorry, didn't merge, just opened a PR yesterday that makes it such that if you edit an XRC, the claim, the corresponding edits are made on the XR immediately. So the idea here is that they're two different lenses or two different views into the same abstraction of the same infrastructure. This is maybe a little bit weird at first, but it starts to make sense when you think about it a little bit more. The audiences of the types are intended to be different. So an XR, a composite resource, is cluster scoped, and it's intended for use by SREs, platform teams, folks who might be providing those as a service to other people. So for instance, most of what's in this example that we're going through here is network plumbing, a bunch of subnets, VPCs, and things like that. You might not, you likely wouldn't, in my experience, need as an SRE team or as a platform team to offer your users the ability to spin up their own VPCs. You might, but I'd say it's probably somewhat rare. However, you may still want to take advantage of Crossplane for this. You might not want to go and apply, 15 different YAML documents to model your network. You might want to put them behind an abstraction that you call my company's opinionated VPC. Or you might even want to go and grab a configuration that AWS has published that's their blessed VPC configuration that they recommend for Crossplane. You might want to pull that down and apply that. But you probably don't want to offer that as a claim. You don't want people to go and create namespace ones of those. So while you can sort of use RBAC to control that as well, the idea here is that by being up at that cluster scope, that very clearly says this is infrastructure, this is for the SRE team to work with. It's not really directly part of any one app. It also allows claims at the namespace level. So inversely or conversely, you could basically say, okay, well, I do have this, the Postgres instance is something that I absolutely want to offer a claim to. I want to allow my users to interact with claims, my development teams, or interact with Postgres instances. So I choose to offer a claim in the terminology we use for that. And one of the reasons that we cross this namespace boundary there is because you might have a VPC, which doesn't really exist in any one namespace. Let's assume that you follow one of the Kubernetes common patterns of putting your infrastructure, giving each of your teams a different namespace. So you've got team A with their namespace and team B with their namespace. And team A shouldn't be able to see team B's infrastructure and stuff like that. So team A creates their Postgres claim, but then you've got this problem of team A has a Postgres claim, team B might have a Postgres claim as well, or a MySQL claim, or a cache claim, and they both want to go in the same VPC, and that's a VPC you operate, and they need some way to relate to that VPC. So that's why we allow things to live up there, like the XR at the cluster scope, so that multiple namespaces can kind of have a relationship up to the cluster scope, because Kubernetes API conventions basically don't allow you to have relationships across namespaces. That's kind of a violation of namespace sort of containerization or separation. Does that make any sense? Or I'm not sure if I answered this sort of what you're asking or not. Nice. All right, and maybe we'll need more questions while we wait for RDS instances to spin up. So all right, you can see that this is all going pretty well. But this RDS instance is still taking a while. So, hey, I can go in here and go kubecon describe RDS instance, and it should tell me what exactly it is doing with its life. And you can see here, this is kind of the kubecon describe sort of pretty version of this. Oops. I think about 5 minutes left in this session, so hopefully we'll get this done. But you can see that back at this Postgres claim, I said that the storage should be 20 gig here. And then if I look at the composite Postgres SQL instance that backs that, you can see that up here, it has basically the same schema, just derived from that claim. It has 20 gig of storage as well. This is where it says, by the way, that it picked the AWS composition. And then if I look at that RDS instance, you can see that this one also has 20 gig, and it also has a heck of a lot of other fields that came with from the composition that you probably don't want your customers to be able to set, or you may, but in my case, I wouldn't want my users to be setting most of these. So those all come from the composition. That's sort of your policy, opinionated policy that you as an SRE can set here. Then you can also see the status, also fairly high definition, like basically anything that AWS's API would tell you about this will tell you too. It all comes out there. And you can just see that it's just not quite ready yet. And let's see. There you go. This is something I've noticed that our RDS instances do lately. They create it and they instantly back themselves up. So they're spending a minute and backing up, and once they've done that, they get the set to show that they're available. Does anyone else have any questions or comments? Thank you. What happens when someone deletes manually a resource created by Crossplane? That's a great question. There's a couple of ways I could interpret it. I think probably what you mean is what happens if someone like goes into the AWS Cloud Console and deletes a resource that Crossplane had created. In that scenario, Crossplane will recreate that resource for you. So it's always driving towards the the declarative state. So if you say there should be an RDS instance, then it'll make sure there's an RDS instance of that name there at all times. So for many different kinds of resources, that can be not always the case. Obviously, a lot of stateful resources like databases may lose their infrastructure, but the idea is that if not today, soon you will be able to. There you go. I can't answer. So there's another question here: is how would it restore data to that RDS instance? I can't personally speak to how the RDS API in Crossplane works. I'm not deeply familiar with that API myself. But usually what will happen is we don't today have any sort of day two operations in Crossplane, so we won't manually orchestrate a backup and restore for you. However, I suspect, off the top of my head, I'm pretty sure that the RDS API supports backing up and restoring itself, so it may actually be possible today to basically write your YAML such that your RDS instance will be backing itself up and to restore from a backup when it is recreated. Not sure if that's actually true or not. So Dan, move off. Feel free to tell me I'm lying if that is the case.
I know that you can create an RDS instance from backup. You'd have to take into consideration here if it got deleted externally and Crossplane recreated it. It would be recreating with that same spec that you provided. So if you didn't initially create it from a backup, then it obviously wouldn't be looking at that. But if you did go in and recreate it yourself, you could reference that. And then another great thing that Nick's point out here, these providers serve as extension points. So you can write, arbitrary logic in Go or really any other programming language to also manage resources and perform some of those day two operations, such as, restoring from backups and that sort of thing.
Yeah, exactly. That's sort of going back to the beginning, the question of like, how do we differ from Terraform? One of these great things about just being a control plane with an API is that, as Dan says, you can just write, we actually hope to do this eventually ourselves, but today, if you were like, well, Crossplane looks great, I just really wish you could restore my databases for me, you have the power to write a Kubernetes operator that works with Crossplane to handle that for you. And as I say, we're aiming to launch V1 of Crossplane at the end of this year, so that'll be close on our roadmap. Next year, we'll be sort of doing more of that day two operation stuff. There was another question in here, which I think was what happens if does Crossplane delete resources that it doesn't know about? No, if you use like an AWS provider, Crossplane doesn't like take over your entire AWS account. If you go and create some resource that Crossplane is unaware of, that resource will happily sit there next to Crossplane. And then in fact, you can import that resource into Crossplane later if you would like. All right, so I know we're pretty much at time, and fortunately the RDS instance just actually became ready, and so now we've got all of our AWS stuff is online. So if I go and describe our composite PostgreSQL instance, I should see that it is now available and ready because all of the resources it created are available and ready. And then if I look at the Postgres plane that created that, I should see that it's available and ready too. I can also see that this one was configured to write its connection data to a secret. So if I go kubectl get secret, I can see that's called dbcon. See some super top secret base64 credentials here that will tell you the username, password, endpoint for that RDS instance. And now, since I'm live on the internet and since that database is actually listening on that port, if you were to go and decode those, I'm going to delete that database. And so you should now see Postgres instance is gone. Composite Postgres instance is gone. And I'm guessing if I do get AWS, you will see that stuff is starting to delete there. We're kind of eventually consistent, so we don't form sort of an ordered graph like Terraform does here, which is sort of has pros and cons. So what we do is we just start telling everything to delete, and then the AWS will say, hey, I can't delete that VPC because there's still subnets in it, and then eventually the subnets will be gone, and then eventually everything will be gone. I feel like I saw a question pop up just now, but as people answering these. Oh, there you go. Folks are answering in chat. Thanks very much, Move Off. All right. Trying to just have a look at the chat here. I feel like we're coming up on time for this session, right? It ends at was it 12:50?
It ended at 12:45. So you can finish up with the last few questions and we'll end out the session.
Nice. All right. It looks like Move-Off is on top of pretty much all of these questions. Oh, hang on. There's some more in the Open tab. How does Crossplane relate to Cluster API? You know, I might ask if Dan wants to answer that really quickly, because I know he's involved with both of those projects to some degree.
Yeah, for sure. I'll touch on that quickly. There's a lot of different dimensions to this. But as you've seen today, Crossplane really mirrors the cloud provider APIs directly. And in fact, actually, if you look at our managed resource API documentation, one of our key tenets is high fidelity with the cloud provider API, which allows you to, take advantage of getting the same error messages back and looking at their documentation. So we don't try and paper over that at all. Cluster API, it's expanding its scope a little bit, but generally the idea is provisioning Kubernetes clusters, not managed Kubernetes clusters like EKS or GKE, which we do in Crossplane by calling out to those cloud provider APIs directly. It would do something like spin up a bunch of EC2 instances and then use kubeadmin to install Kubernetes onto those and get a cluster running, and then give you back your kube control information to talk to that. That's definitely something that's obviously valuable, right? It's just a different interface for being able to talk to Kubernetes clusters. And we're actually talking with a bunch of the cluster API folks today on two different dimensions. One of them being you can write a Crossplane provider for anything. So we actually have in the works right now a provider CAPI, or a provider cluster API, to point at those cluster API resources. So you could create those and then you could abstract them into higher level things. So as Nick was talking about with compositions, you could have an EKS cluster in there, or you could have a cluster API cluster in there. So it's just kind of another level of abstraction. The cluster API folks, actually the folks who are really intimate with that project, have reached out to us in turn and looked at, going the other way, right? So we provide these managed resource primitives. So as I mentioned before, Cluster API, for instance, their AWS provider will spin up EC2 instances. It'd be a lot easier for them to just say, oh, create one of those EC2 custom resources that Crossplane's provider AWS brings along, and it's going to give us connection information, and we'll just use that as the interface. So you can see that we're kind of like sandwiching what Cluster API is doing right there. The real value that they bring, in my opinion, is having deep knowledge of how to run Kubernetes clusters, as opposed to actually spinning up and managing infrastructure.
So given we're pretty much in time, I did want to encourage everyone, if you're not already, please join our Slack. We would love to hear more from you, and we'll be hanging out. I'm going to be hanging out at the Crossplane booth. I think Phil is too, pretty much directly after that. And we'll have a live Zoom there that you can hop on and chat to us. But we're on Slack all the time, and there's a great community there where plenty of other folks will be able to help you out. And as you might be able to see on my screen, I believe that we're still running this survey where you can win a box of swag if you join Crossplane Slack. I think we're also doing something else where if you go to the Upbound, so Upbound is the company that founded Crossplane and is behind it. Most of us maintainers, not all of us, but many of us work for Upbound. I believe we have a booth as well, and I think they're giving away a green screen if you go past that booth. So I definitely recommend checking that out, and you can hear about our Upbound Cloud product, which is pretty cool, built onto Crossplane. All right, thanks everyone. Thanks for coming by.
Yeah, thanks everyone, and thank you to all you maintainers for joining us today and talking about the project. We really appreciate you taking time out of your day and speaking with our attendees. We appreciate that.
Yeah, thanks for running the event.
Yeah, thanks, Katie.
Have a great day, everyone.
Thank you.